Okay, now we're going to see how to graph the inverse of a function if I'm giving you the graphical expression of a function f. So the first thing we have to remember is that f and f inverse undo each other. And also from the review from discrete functions, we know that if f sends a value x into y, the inverse function is going to send back that y into x. So the first thing we have to do to graph inverse function is to firstly identify a coordinate points in the function f. So looking at my graph here, I can see that for x equals -5, my function has a value of 2. So I can start drawing or writing these points. Another easy point to identify could be -1, 6. Another easy one could be -3, 4. And let's look here. Another easy to identify point could be 7, I'm just gonna color them. The last point is 7, 3. So all of these points are in my function, in the graph of my function, and they have, for a value of x, they have a value of y. That is, my function sends this value of x into this value of y. And because I know that my inverse undoes that, my inverse is going to send 2 into -5, 6 into -1, 4 into -3, and 3 into 7. So let's start plotting these points. 2, -5. 6, -1. 4, -3. And 3, 7. So now that I have all these points, I have to know how my graph looks like. For that, we have to use this property that says that f and f inverse are symmetric with respect of the identity function. This line we have here is the identity function. The identity function is f of x equals x. So the drawing I'm going to do right now has to be symmetric with respect of this line. So if this is a finish point, 7, -1, 7, 3, I should start my graph in that point, 3, -7. So let's see what my function does. From here, I can see that my function starts from this point, crosses the symmetry angle, touches another point, and goes into the last point. My inverse function is going to do the same. I'm going to start in the inverse point from this starting point. So for 7, 3, the inverse is 3, 7. And I know if I advance, I'm going to cross my symmetry line, touch another point, and from there I touch these other 2 points. So as you can see, the graph of the inverse function is symmetric with respect of this line. So f and f inverse are symmetric. Let's do another example. Here we have this function. So the first thing we have to do is to identify points in this graph. For example, this is an easy point to identify. This is -6, 2. Another point in this graph that it's easy to identify is this one, -5, 0. Let's see, another point that is easy to identify is this one, -2, -2. And let's choose another one. Here's another one, 3, -4. So I know that the inverse function is going to have the symmetric or the inverse coordinate pairs, and they look like this. And now I'm gonna plot these points. The first point is 2, minus 6. 0, minus 5. Minus 2, minus 2. And minus 4, 3. Now that I have my points, I should ask myself, how do I start this graph? Always start your graphs by using the inverse point of a starting point. So in this case, the starting point is minus 6, 2. So start graphing the inverse from that inverse coordinate, 2, minus 6. So if I start here, my graph is gonna go like this and go all the way up. And as you can see, these two lines are symmetric with respect of the identity function.